Welcome everyone. We are discussing probability. Today I will solve problems of probability based on permutation. So to solve problem based on permutation, you should have clear knowledge in the chapter of permutation. So for any difficulty, you can consult my videos regarding permutation. So today I will solve some problems of probability using letters and words. So problem number 1, you look. The letters of the word Clifton are placed at random in a row. What is the probability that two vowels come together? The letters of the word Clifton are arranged in a row. What is the probability that two vowels come together? Now look, Clifton. So all the letters are different. You know, if letters are different, some letters are same. So different type of problem and different theory of permutation to be used. So Clifton. So 7 letters. You know, 7 different letters can be arranged in a row in factorial 7 ways. So this is n. So n equals to total outcomes equals to number of arrangements of 7 letters, 7 different letters in a row equals to factorial 7. Now look, what is the probability that two vowels come together? Now what are the vowels? Vowels are I and O. So you know, vowels are together. For this type of problem, we take two vowels as a single entity. It is actually problem of permutation. So, considering two vowels as a single one, a single entity, we have 1 plus 5 equals to 6 letters. So considering this as 1 and different, 7 different, so 1 plus 5 equals to 6 letters. They can be arranged in factorial 6 ways. Now two vowels I and O, so they can be arranged in I first, then O, then O first, then I. So two vowels can be arranged. If there are 3, then factorial 3 in factorial 2. So this is possible outcome. So number of arrangements in which two vowels are together equals to factorial 6 into factorial 2 by FPC, factorial 6 into factorial 2, and this is favorable outcomes M. So N is very simple. So 7 letters, they can be arranged in factorial 7 ways. Now, what is the condition? Two vowels come together. So probability of two vowels come together equals to M by N. So factorial 6 into factorial 2 by factorial 7. So you calculate it and you get factorial 6. So 7, so this is factorial 6 into factorial 2, 7 into factorial 6. 6 is cancelled, so 2 by 7. So required probability is 2 by 7. So we need idea of permutation. So without the idea of permutation, you cannot solve this type of problem. Now, problem number B and C, they are of same types. The letters of the word social are placed at random in a row. What is the probability that three vowels, here three vowels come together, and then society, same problem. Three vowels come together. Now they are of same type. So you solve B and C. So look, I am giving some hint. Total letters. So 6. So all are different. And vowels are O-I-A. So what is N? N equals to arrangements of letters of the word. So this is factorial 6. Now, what is the probability that three vowels come together? So considering three vowels as a single entity. So how many letters? 1 plus 3 equals to 4. 4 letters. So they can be arranged in factorial 4 ways. So just like the previous one. But three vowels, different vowels, can be arranged in factorial 3 ways. So in the previous, there are two vowels, so factorial 2. So favorable cases equals to vowels are together. So by FPC, factorial 4 into factorial 2. So what is the probability? Required probability M by N. So factorial 4 into factorial 3 by factorial 6. So this is factorial 4. Factorial 3 is 6. So 6 into 5 into factorial 4. So 1 by 5. So final answer is 1 by 5. So very important and simple problems. if you have idea in permutation. Next one. Now consider the next one. Find the probability that in a random arrangement of the letters of the word university, the two I's do not come together. Do not come together. In the previous one, vowels are come together. Here, two I's do not come together. So, you look, university. So, total letters equals to 10. So, what are the repeated letters? I, 1 and 1. Rest are different. Rest are different. Now, so total number of arrangements n equals to total number of arrangements without any restriction. So factorial 10 by factorial 2. Why factorial 2? Because there are 2 I. Now, what is the restriction? 2I do not come together. We first find probability that 2I will come together. So same process, considering 2 I's as a single one, there are 1 plus 8 equals to 9 letters. Rest 8 are different. So 8, and considering 2 I's, so they can be arranged in factorial 9 ways. And there are 2 I's. Look, I. If you interchange, no change. So 2 I's can be arranged in factorial 2 by factorial 1. You can write it directly. So favorable outcomes means number of arrangements in which 2 I's are together. So by FPC, factorial 9 into 1. So just like the previous one. So probability that 2 I's are together equals to factorial 9 by factorial 10 into by factorial 2. So factorial 9 into factorial 2, and 10 is 10 into factorial 9. So simplifying, we get 1 by 5. So 1 by 5. Now required probability. So what is the required probability? 2 I's are not together. Probability that 2 I's are not together equals to 1 minus probability that 2 I's are together. So 1 minus 1 by 5 equals to 4 by 5. So simple problem, but most important for JEEMAIN and WBJEE. So this is also same type of problem. Now consider the next problem. If the letters of the word assassination are arranged at random, obviously in a row, find the probability that 4 S's come consecutively in the word. 4 S's. Now look, assassination. So total letter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now 4 S's. 1, 2, 3, 3 A's. 2 I and 2 N. T and O are different. So N equals to total elements. Total number of elements without any restriction. So total outcome. So this is very simple. Total letters by repeated letters. By repeated letters. Now you have to find 4 S's come consecutively. 4 S's. So same type, that of previous. We consider this as single one. So this as single one and remaining 9 minus 4. So total 13. 13 minus 4 is 9. Remaining 9. So considering 4 S's as a single one, total letters equals to 1 plus 9 equals to 10. They can be arranged in factorial 10 by factorial 3, factorial 2, factorial 2, because we considering 4 letters as a single entity, so this 4 will be not present. Now four S's can be arranged in factorial 4 by factorial 4. So they are of same, so only one. No need of writing this one. So aim equals to favorable outcomes for the event, that is 4 S's are consecutive. It is not problem of permutation, so you can write directly n. So by FPC, factorial 10, factorial 3, factorial 2, factorial 2 into 1. Now, what is probability? For case A, P, 4 S's are together equals to factorial 10 by factorial 3, factorial 2, factorial 2, factorial 13 by factorial 4, factorial 3, factorial 2, factorial 2. So this will be cancelled out. Now if we simplify, so look, this factorial 4 will be at the numerator. So factorial 10 into factorial 4. And factorial 13 is 13, 12, 11, 10 into factorial 10. So factorial 10 is cancelled out. So 4. So 4 into 3 into 2 by 13 into 12 into 11. So 12, 12 cancel. So answer is 2 by 13 into 11. 2 by 13 into 11. So we are getting the result. 2 by. So 2 by 13 into 11. So 130 into 13. 130 into 13. 143. 2 by 143. Now 4 S's are come together, just like the previous one. Next, now we consider problem number 2. 2 I's and 2 N's come together. So N equals to total outcome. So this is factorial 13 by factorial 4, factorial 3, factorial 2, factorial 2. Now 2I and 2I and 2A's are together. So considering 2I's and 2A's as a single one, we have 9, 10 minus 4. So we considering this as 1 plus 1. 10, this is 13 minus 4. 13 total minus 4 plus 1 equals to 10 later. So they can be arranged in factorial 10 by factorial 4 into factorial 0. Why factorial 4? Because there are 4 S's and factorial 3 2A's. Now two I's and 2AN, not S. I think this is 2N. 2N. This is not I. 2N. 2N. And now 2I and 2N are placed in a row. Are placed in factorial 4 by factorial 2 into factorial 2 square. Factorial 2 for 2I and 2N. Therefore, by FPC, fundamental principle of counting, total number of arrangements in which 2I and 2N's are together equals to factorial 10 into factorial 4 into factorial 3. This is it. And second one. So factorial 10 by factorial 3, factorial 2 will do. So this one. So this is as favorable cases n. Favorable cases n. Now what is the total probability? Now this is n and this is n. So required probability for this case. So probability that two I's and two NA's are together equals to m by n. So what is m? Factorial 10 by factorial 3, factorial 2, factorial 2. Factorial 13 by 4, factorial 3, factorial 2, factorial 2. So this one is cancelled out. Now if we simplify it, so factorial 10 and factorial 4 by factorial 13. So 10, 4, 3, 2, 1 and factorial 13, 12, 11 into factorial 10. So 10, 10 cancel. 4 into 3 is 12. So 2 by, so we are getting 2 by 13 into this. 130 plus 13. So 143. So probability that two I's and two N's are together equals to 2 by 243. So same type of problem. Considering this as single one, then arrangements of two I's and two N's. Now problem number C. Problem number. So no two A's coming together. No two A's. How many A's? So A 3 and rest 10. So that is S, 2I, 2N, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now look, there are how many gaps? 1, 2, 3, 4, 5, 6, 7, 8, 9. And this experiment N and this. 9 gaps. There are 9 gaps. 9 gaps between them and 2 extremes. So total 13 gaps. So if we place in 13 gaps 3 A's, then no 2 A's are together. So this is difficult problem of permutation. So no 2 A's. Look the language, no 2 A's. So you arrange the letters other than A's. Then you are finding that there are 11 gaps. So write 10 letters can be arranged in, not in factorial 10 because there are repetitions. Factorial 4, factorial 2, factorial 2 twice. 5 factorial 10, so total 10. 4 S's, repetition, 2 I's and 2 N's. So 10 letters can be arranged in this. There are total number of 11 gaps. 11 gaps. Look, this cross, 9 in between them and 2 extreme gaps. If we place 3 A's in 11 gaps, then no two A's are together. So this can be done in 11 C3 ways. Out of 11, 3 A's are different, so that is 11 C3. Otherwise, you can take 11 P3 into 1 by factorial 3 because 3 A's are alike. Now, by FPC, AM equals to number of favorable cases equals to factorial 10, factorial 4, factorial 2, factorial 2 into 11C3. 11C3. This is M. So what is the probability for third case? Probability that no two A's are together equals to M by N equals to 11C3 into factorial 10, factorial 4, factorial 2, factorial 2. And this is factorial 13, factorial 4, factorial 3, factorial 2, factorial 2. So this one is cancelled. So if we simplify, so what we are getting, 11C3, factorial 11, factorial 3 into factorial 8, factorial 8 into factorial 10 by factorial 13, and these 3 will be at the factorial 3 will be at the numerator, So 3, 3, factorial 3, 3 cancel out. Now 11 unchanged and factorial 10, this is unchanged. This is factorial 13. So 13, 12, factorial 11 into factorial 8. So it is cancel out. Factorial 10 is 10 into 9 into factorial 8. So 13 into 12 into factorial 8. So this is 3. So 10 into 3. 10 into 3. 10 into 3. So 13 into 4. So 10, 3 into 3. So 3 into 9. This is 4. So this is 5 into 3 by 13 into 2. So 5 into 3. 13 into 2. So 15 by 26. 15 by 26. So this one is difficult. No two A's, no three, two A's are together. So in these cases, so you arrange the letters not involving A. So how many letters? So 13 minus 3 equals to 10. So 10 letters can be arranged in factorial 10, factorial 4 into factorial 2x. And you place them in a row and find the gaps in between them. There are 11 gaps. If you place 3 A's in 11 gaps, then our condition is satisfied. That is, no 2 A's are together. So this can be done in 11C 3 ways. So favorable cases 11C3 into this, totally very simple and simple. So today I have solved problems involving permutations. These are most important for competitive exams. So last one is difficult. You should have clear knowledge about arrangements of letters of the word in a row. Whether elements are, that is, letters are same or different. So, if you have clear idea in permutation, you are able to solve this type of problem. So, thank you for today.